Hello student, how are you? I hope all of you are good and safe. Student, now we are solving question that has been asked by you. Exercise 2.1, question number 6, part 1st, simplify. How we can solve this question? First we are solve the bracket. 3 raised to the power minus 1. We can write as a 1 upon 3. 1 upon 3, because we know that a raised to the power minus n, a raised to the power minus n is equal to 1 upon a raised to the power n into 3 raised to the power minus 2. We can write as a 1 upon 3 raised to the power 2 divided by 3 raised to the power minus 3 1 upon 3 into 3 square, we get 9 divided by 3 raised to the power minus 3 1 upon 3 into 1 upon 9, we get 1 upon 27 divided by 3 raised to the power minus 3, 1 upon 27 divided by 1 upon 3 raised to the power 3, we get 27. Now 1 upon 27, division sign has to be converted into multiplication sign and take the reciprocal of 1 upon 27. We get 27 upon 1. Twenty-seven cancel. We get 1 upon 1, which is equal to 1. Now our next topic is laws of exponent with integral powers. Starting with law first. If x is a non-zero rational number and m and n are any two integers, then x raised to the power m into x raised to the power n is equal to x raised to the power m plus n. For example, so that 3 raised to the power 7 into 3 raised to the power minus 5 is equal to 3 raised to the power 7 plus minus 5. How we can solve this? This is our LHS side. And this is our RHS side. First we solve our LHS. LHS is equal to 3 raised to the power 7 into 3 raised to the power minus 5 which is equal to 3 raised to power 7 into 3 raised to power minus 5. We can write as a 1 upon 3 raised to power 5. 3 raised to power 5. Because we know that a raised to power minus n is equal to 1 upon a raised to power n. 3 raised to power 7 into 1 upon 3 raised to power 5. 3 raised to power 7 divided by 3 raised to power 5. We get 3 raised to power 2. Our LHS is equal to 3 raised to power 2. Now, we solve our RHS. RHS is equal to 3 raised to power 7 plus minus 5 3 raised to power 7 plus minus minus 3 raised to power 7 minus 5, we get 2. Hence, LHS is equal to RHS. Law second. If x is a non-zero rational number and m n are any two integers, then x raised to power m divided by x raised to power n is equal to x raised to power m minus n. That is, x raised to power m upon x raised to power n is equal to x raised to power m minus n. For example, verify the statement 11 raised to power 6 divided by 11 raised to power 4 is equal to 11 raised to power 6 minus 4. How we can solve this? We know that this is our LHS and this is our RHS. First, we solve our LHS. Is equal to 11 raised to power 6 divided by 11 raised to power 4 is equal to 11 raised to power 6 divided by 11 raised to power 4. We can write as a 11 raised to power 6 upon 11 raised to power 4. 11 raised to power 6 divided by 11 raised to power 4. We can write as 11 raised to power 6 into 11 raised to power minus 4. 11 raised to power 6 into 11 raised to power minus 4. We get 11 raised to power 6 plus minus 4. Because we know that a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. Eleven raised to the power 6 plus minus minus 4. 11 raised to the power 6 minus 4. We get 11 raised to the power 2. Our LHS is equal to 11 raised to the power 2. Now we solve our RHS. Is equal to 11 raised to the power 6 minus 4. 11 raised to the power 6 minus 4 is equal to 11 raised to the power 6 minus 4. We get 2. Our LHS is equal to our RHS. Hence, LHS is equal to RHS.